Think about what happens when you flip a light switch. The room doesn't fill up with light slowly, like a pool filling with water, it just happens instantly. For almost all of human history, great minds believed light was instantaneous. Aristotle thought it was an omnipresent force. Rene Descartes argued that if light took any time to travel at all, his entire philosophy of science would crumble. But in the early 1600s, Galileo Galilei decided to test it. Galileo and an assistant stood on two different hills less than a mile apart in the dead of night. Each held a covered lantern. Galileo would uncover his lantern, and the moment his assistant saw the light, he would uncover his. Galileo tried to measure the delay. The result? Nothing. Light moved too fast for human reflexes. Galileo concluded that if light wasn't instantaneous, it was at least extraordinarily rapid. But how do you measure something that moves faster than anything else in the universe using primitive tools? To solve the mystery, humanity had to stop looking across hills and start looking at the solar system. Ole Rømer, a Danish astronomer working at the Paris Observatory in 1676. Rømer wasn't actually trying to measure the speed of light. He was trying to map out a precise cosmic clock using Jupiter's moon Io. Io orbits Jupiter like clockwork. Every 42.5 hours, it plunges into Jupiter's shadow, disappearing from view. Rømer noticed something bizarre. When Earth was closest to Jupiter, Io's eclipses happened exactly when predicted, but as Earth moved further away in its orbit around the Sun, the eclipses start falling behind schedule. By the time Earth was on the exact opposite side of the Sun, the eclipses were delayed by roughly 22 minutes. Why? Was Io slowing down? Was Jupiter pulling it differently? Had astronomers made a mistake? No, the moon wasn't changing, the light was. The light coming from Io had to travel a much greater distance before reaching Earth. By dividing the diameter of Earth's orbit by that 22-minute delay, Rømer made history. He proved light had a finite speed, calculating it at roughly 220,000 kilometers per second. He was off by about 26% because planetary distances weren't fully accurate yet, but he shattered the illusion of instant light. This was much more than a clever astronomical observation. For the first time, scientists knew that information from the universe didn't reach us instantly. Every star, every planet, every galaxy we see is actually a snapshot from the past. Even the sunlight warming our face right now left the sun about 8 minutes ago. For nearly 2 centuries, the speed of light remained a purely astronomical measurement. But by the mid-1800s, two French physicists, Hippolyte Fizeau and Léon Foucault, decided to bring the light down to Earth. They wanted to capture it inside a lab. Let's look at Fizeau's mind-bending experiment from 1849. Imagine trying to stop something moving nearly 3,000 kilometers every second using nothing more than a spinning bicycle gear. That was essentially Fizeau's challenge. He set up a light source and beamed it through the gaps of rapidly spinning toothed cogwheel. The light traveled 8 kilometers, about 5 miles, to a distant mirror, bounced off it, and traveled 8 kilometers right back to Fizeau's eye. When the wheel was spinning slowly, the returning light passed perfectly back through the same gap. But as Fizeau cranked up the speed of the wheel, something fascinating happened. The wheel spun so fast that by the time the light made the 16-kilometer round trip, a solid tooth had rotated into position, blocking the returning beam completely. Because Fizeau knew exactly how many teeth the wheel had and exactly how fast it was spinning, he calculated the precise fraction of a second it took for a tooth to replace the gap. He clocked the speed of light at 313,300 kilometers per second, extremely close to the real answer. Shortly after, his rival, Léon Foucault, swept the cogwheel from spinning mirror. By measuring the tiny angle at which the returning light deflected off the moving mirror, Foucault brought the measurement within 1% of the true value. By the 20th century, we traded spinning wheels for lasers, microwaves, and quantum physics. Scientists realized that light is an electromagnetic wave. If you know the exact frequency of an electromagnetic wave and you can measure its wavelength, You can multiply them together to get its speed. By the 1970s, laser interferometer and atomic clocks had measured the speed of light with incredible precision. The uncertainty had become smaller than our ability to define the meter itself. So in 1983, scientists made a revolutionary decision. Instead of measuring the speed of light, they defined it to be exactly 299,792,458 meters per second. From that day on, the meter was defined as the distance between light travels in a vacuum in 1 over this number of a second. We no longer use the meter to measure the speed of light. Instead, the speed of light defines the meter. From Galileo trying to place lanterns across Italian hills, to Rømer looking at the moons of Jupiter, to modern physics using lasers, unlocking the speed of light was a multi-century relay race of human ingenuity. Only a few decades later, Einstein would build an entire theory of space and time around this number. The speed of light wasn't just fast, it turned out to be the ultimate speed limit of the universe. The next time you switch on a light, remember that you are witnessing the fastest thing in the universe, a mystery that took humanity more than 2000 years to solve. Thanks for watching, see you next time.